I was standing in my kitchen this morning, holding a single multivitamin up to the light, just staring at it. And it occurred to me that I treat this thing like it's a piece of fruit, you know? I swallow it, I expect it to make me healthier, and I move on.
Right.
But looking at it closely, the seam, the perfect glossy finish, the fact that there is a precise amount of powder inside, it's not food, it's a machine.
It's a delivery system.
Yeah.
We tend to think about the health part, the vitamin C or the zinc, but the vessel itself, that is pure high-speed engineering.
And that's what we're taking apart today. We are stopping the assembly line to look at the hidden science of the capsule. We're basing this deep dive on the manufacturing protocols and technical guides from superior supplement manufacturing. Essentially, we have the blueprints.
We do. We have the blueprints for how a billion-dollar industry builds these little submarines we all swallow every morning.
Submarine is a great analogy.
Well, it is, because the goal of the capsule is to navigate a very hostile environment, your stomach, and deliver a payload intact. To do that, you have to master material science, fluid dynamics, and some pretty intense physics.
It's surprisingly complex for something that costs a few cents. But before we get into the, the really high-tech stuff like capsules inside of capsules.
The fun stuff.
Yeah, we have to start with the shell. If I pick up a standard bottle from the drugstore, what am I actually holding?
Statistically, you are holding a byproduct of the beef industry.
So cows.
Yes, specifically the collagen derived from cattle hides and bones. And there's a reason it's the standard, what we call the 1.0x cost factor.
Okay.
It's not just because it's cheap, though that helps. It's about the mechanics. Gelatin has this unique ability to cross-link and form a mesh that is incredibly strong when dry.
But it falls apart in your stomach.
But it dissolves rapidly at body temperature. Your body knows exactly what to do with it.
It works, so why fix it? But I know for a fact that the plant-based sector is just dough. It's eating into that market share aggressively.
Oh, absolutely.
If you can't use gelatin, what are you using? Because last I checked, you can't melt a salad into a hard shell.
No, not quite. This is where the chemistry gets interesting. The standard vegetarian alternative is HPMC.
HPMC.
Hydroxypropyl methylcellulose.
That sounds decidedly less natural than cow.
It's essentially wood pulp. It's L-glucose derived from pine or poplar trees, chemically modified to behave like gelatin.
So it's a plant-based copy.
It's a marvel, really, because it's so stable. Gelatin can get brittle if it's too dry or sticky if it gets too wet. HPMC is robust, but mechanically, it's not quite as snappy as gelatin, and it dissolves a bit slower.
And it costs more.
It does. You're paying for that processing, so 1.8 times the cost of gelatin.
So you pay a premium for the veggie label.
You do. But if you want the real high-end engineering, you look for pullulan.
Pullulan. Never heard of it.
It's a polysaccharide produced by fermentation, so basically fungus. The reason manufacturers use it, despite it being more than double the cost of gelatin, is the oxygen barrier.
Meaning air can't get through the shell.
Exactly. HPMC is a bit porous at a microscopic level. Oxygen can sneak in. If you have a super sensitive ingredient, maybe a high-end antioxidant that degrades the second it touches air, pullulan is the only way to safeguard it.
So it's like an edible, hermetically sealed jar.
That's a perfect way to put it.
Okay, so we've picked our material. Now we run into the thing that actually annoys me, and I think most listeners the most. The size.
Ah, yes.
Why are some of these pills so aggressively large? I'm talking about the horse pills that you have to mentally prepare yourself to swallow.
I know the ones. And believe it or not, manufacturers hate making those too.
I find that hard to believe.
No, really. They know consumers hate them. But they are fighting a losing battle against physics. In the industry, capsule sizes work on an inverse scale. So size 4 is tiny, size 1 is standard. The monster you're talking about is the size 00.
000.
000.
That sounds like a weapon caliber.
It practically is. It's over 26 millimeters long.
Huh?
But the reason they use it comes down to a concept called bulk density.
Walk me through that.
Okay, imagine you have a gram of lead and a gram of feathers.
Right. Same weight, wildly different volume.
Exactly. In the supplement world, minerals like calcium or vitamin C are the lead. They are dense, heavy powders. You can pack a lot into a small space.
But botanicals, dried herbs, reishi mushroom powder,
Feathers.
Or
Or worse, it's like trying to pack down a duvet. It's fluffy, aerated, and stubborn. And this is where the machinery is crucial. These encapsulation machines aren't just funnels. They use tamping pins.
Tamping pins, like a piston.
Exactly. Imagine a tiny steel piston that punches into the powder pile to create a compressed slug of material.
Okay.
It has to force the air out and make the powder hold a shape before it even slides into the capsule body. If the powder is too fluffy, low bulk density, the piston can't form a slug. It just bounces back. It's elastic.
So the machine physically cannot compress it enough to fit into a normal-sized pill.
Correct. So to get the dosage on the label, say 500 milligrams of that fluffy herb, you have no choice but to increase the volume of the container. You have to upgrade to the size Del 00. It's not a design choice. It's a spatial necessity.
That actually leads to my next grievance. Sometimes I get a capsule, usually the clear ones, and I hold it up to the light, and it's half empty. It's a huge air gap.
The settling effect.
And my first thought is, I'm getting ripped off. Why didn't they just use a smaller capsule?
I promise you, it wasn't empty when it left the factory. Remember that tamping process?
Oh, slug.
When that slug is formed and shot into the capsule, it's under mechanical stress. But over time, shipping, sitting in a warehouse, vibrating on a truck, the powder structure relaxes. It settles down.
Like a bag of potato chips.
Exactly like a bag of chips. The weight is exactly what's on the label, but the volume has surrendered to gravity.
So it's cosmetic.
Entirely.
Yeah.
But it drives customer service teams crazy because everyone thinks it's a manufacturing defect.
Let's shift gears to the stuff that isn't powder. I've seen a rise in liquid-filled capsules, fish oil, vitamin D, and then the really fancy stuff, the beadlets. Is that just marketing?
It could look like that, yes, but there's usually a pharmacokinetic reason for it.
A pharma what?
Pharmacokinetic.
Yeah.
How a substance moves through the body. Liquid filling is difficult. You have to literally weld a ring of gelatin around the seam to seal it.
To stop leaks.
To stop leaks. But you do it because bioavailability is often higher in liquid form. Your body absorbs it better.
Okay, that makes sense. But what about the beadlets, the little colored spheres inside the capsule?
That is all about timing. If you take a standard powder capsule, it dissolves, and boom, you get 100% of the dose at once.
Right.
But with beadlets, you can engineer the coatings on them.
Different thicknesses.
Exactly. You can have 20% of the beads dissolve instantly. Another 30% dissolve in 2 hours. The rest dissolve in the lower intestine 4 hours later. You are programming the pill.
So it's a time-release system.
A very precise one.
That's impressive. But then I saw something in the Superior supplement notes that it stopped me in my tracks. Capsule in capsule.
The nesting doll.
Yeah. A small capsule floating inside a liquid-filled larger capsule. This feels like we've crossed the line into just showing off. Is there any real reason for this?
It's niche, but yes. It solves two big problems. One is chemical incompatibility. Let's say you want to combine a probiotic with a specific oil, but the oil would kill the bacteria if they touched directly.
So you build a wall?
You put the bacteria in the inner capsule, float it in the oil, and they never meet until digestion begins. The second reason is that dual release profile.
Okay.
The outer liquid hits you instantly. Maybe it's caffeine for energy.
Yeah.
The inner capsule takes longer to break down, giving you a sustained release of something else later on.
Mechanically, though, how do you even build that? Dropping a pill into a liquid without it dissolving?
The speed has to be incredible. The machine fills the outer body with liquid, drops the pre-sealed inner capsule in, and snaps the lid on in a fraction of a second. If it hesitates, the whole thing is ruined. It's the Formula 1 of manufacturing. And the cost reflects that. You're looking at a 2.5x price hike for that tech.
So if I see that on a shelf, I'm paying for the engineering as much as the ingredients.
Absolutely.
I want to touch on a controversy. You can't talk about supplements without talking about the other ingredients list.
The stuff at the bottom?
Yeah. Magnesium stearate, silicon dioxide. There's a very loud movement online that says these are toxins or, at best, cheap fillers.
This is the battleground between clean label marketing and industrial reality. From a manufacturing perspective, calling them fillers is a misunderstanding of physics. We call them excipients.
Excipients.
And they aren't there to take up space. They're there to keep the machine from exploding.
Exploding.
Well, maybe not exploding, but certainly jamming or melting. Think about that high-speed machine again. It's running 250,000 capsules an hour. Metal parts are moving at a blur. That creates friction. Friction creates heat.
And heat kills vitamins.
Precisely. If you are running a sticky herb without a lubricant, the friction can literally cook the nutrients inside the hopper. Magnesium stearate is a flow agent. It coats the particles so they flow like water, and it reduces friction.
So without it, you get inconsistent dosing.
You get inconsistent dosing, you get jammed pistons, and you get heat damage. Now, silicon dioxide. That's basically sand. We use it as an anti-caking agent. It keeps the powder from turning into a solid brick.
But the clean label people say you can make pills without them.
You can. It's called the no excipient challenge. But here's the trade-off. You have to run the machine at half speed or quarter speed.
That's a much slower.
And you have to stop constantly to clean the tooling. That drives the cost of goods up significantly. So when you buy a magnesium stearate-free product, you aren't paying for better ingredients. You're paying for the inefficient machine time it took to make it.
That's a fascinating way to frame it. You're paying for the slow lane. Let's talk about the business side of this. Because looking at these protocols, it seems like a massive operation. But I see influencers launching their own brand of vitamins every other day. How are they building factories?
No, they are using contract manufacturers. But there is a huge barrier to entry that people don't realize. It's the MOQ.
Minimum order quantity.
Minimum order quantity.
So I can't just call them up and ask for 50 bottles for my friends.
They wouldn't even pick up the phone. For a custom formula, meaning you chose the ingredients, the standard minimum is usually around 2,500 bottles.
2,500.
And that's on the low end. If you want those fancy liquid capsules or the beadlets, you are looking at a minimum run of 1 million units.
1 million? Why so high?
It's the setup and the cleanup. This is the part of the industry nobody sees. Between every single production run, the entire room and every piece of machinery has to be stripped down and sanitized.
To prevent cross-contamination?
Exactly. We're talking about swabbing surfaces to test for parts per million of the previous ingredient so you don't accidentally get caffeine in your sleep aid. That cleaning process can take as long as the production run itself.
So it's just not worth it for them to do a small run?
It costs some money just to turn the lights on for a small order.
And how long does it take? If I have my 2,500 bottle order ready to go, is it quick?
In a post-COVID world, no. You are looking at 10 to 12 weeks for a first-time order.
3 months.
Easily. They have to source the raw ingredients, which might be coming from 3 different continents, bring them in, quarantine them, test them for identity and heavy metals.
Yeah.
That's all before they even turn on the mixer.
It's a huge logistics chain.
A slow, methodical one.
One thing I found really surprising was the section on expiration dates. I always assumed that was a hard science determined by the factory.
That is one of the biggest misconceptions in the game. The manufacturer will usually slap a standard 2-year date on the bottle. But the legal liability for that date, that sits 100% with the brand owner.
So if I'm the influencer selling the vitamins, I have to prove they are still good in 2 years.
Technically, yes.
Yeah.
You're supposed to pay for stability testing, where a lab keeps your bottle in a chamber for 2 years and tests it at intervals. Most small brands can't afford that.
So what do?
They use a loophole. You ever notice some bottles say MFG date or manufactured on instead of MSP?
I have. I usually find it annoying because I have to do the math.
It's not just math. It's a liability shield. By stating when it was made, they are telling you the truth without making a legal claim about how long it lasts. They are putting the burden on you.
That is sneaky. I am going to be checking my entire cabinet for that tonight.
It's worth a look.
We've covered a lot of ground here, from the molecular structure of the shell to the physics of the tamping pin, all the way to the legal loopholes on the label. It really does change the way you look at that little pill.
It should. It's an industrial marvel. And honestly, despite the rise of gummies and powders, the capsule remains the king of delivery.
Really? Even with everything else out there?
It protects the ingredient from oxygen, it masks the taste, and it's incredibly precise. It's just the cleanest way to get a nutrient into the system.
So, before we wrap up, I have to ask about the future. We see personalized nutrition coming, DNA-based diets, that sort of thing. Are we heading toward a world where we abandon the bottle?
I think we are heading toward the poly pill.
Poly pill.
Instead of taking 5 different pills from 5 different bottles, you use that capsule and beadlet technology to build a single custom stack.
So 1 megapill.
1 megapill, maybe printed on demand, that releases your B vitamins in the morning, your iron at noon, and your magnesium in the evening. The technology is there. It's just a matter of scaling the cost down.
A 3D printed, time-released, all-in-one daily.
Exactly. But until then, we're stuck with the 000 horse pills.
Unfortunately so. Well, next time you take your morning vitamins, take a second to look at the other ingredients. If you see magnesium stearate, don't get mad.
Just appreciate that the machine didn't overheat.
And that you aren't paying for the slow lane.
My pleasure.
And thanks to you for listening. We'll see you on the next deep dive.